You reboot a critical server after a patch cycle, expecting the normal boot screens to appear. Instead, the screen goes completely black, save for 5 characters: grub, right angle bracket, cursor. This prompt is a generic signal that GRUB has lost its way. It means the BIOS successfully found the bootloader binary, but GRUB cannot find its configuration file or the path to the kernel files required to start the operating system. To bypass this without resorting to a destructive reinstall, you need 2 things: direct console access to the machine and a minimal Linux Live ISO. We are going to manually reassemble the system's file system from a live environment using a technique called chroot. This allows us to step inside the broken OS and rewrite the configuration without losing any data. Step 1 is securing a functional workspace. Attach the minimal installation ISO to your server and boot into its live environment. From this live terminal, execute the command lsblk. This will read the physical drives and map out the server's local disk layout. Looking at the lsblk output, first identify the primary root file system, listed under a mapper path like dev mapper vg0 root. Next, locate the dedicated boot partition, typically a smaller block device labeled dev sda2. Pinpointing these 2 exact partition pathways is mandatory. Mounting the wrong drives here means the recovery commands will fail soundly. With the drives identified, we construct an environment cage by mounting the damaged root file system into a temporary directory named mnt. The exact sequence matters. Mount the root first, then immediately mount the boot partition inside that cage at mnt/boot. The files are now accessible, but the internal package manager and repair tools are currently blind to the physical server hardware. They require live access to hardware telemetry to function, which is managed by pseudo-file systems like dev, proc, and sys. This shell loop syntax on screen maps that telemetry. It binds these specific live system directories directly into your newly constructed /mnt cage. Skipping this pseudo-file system binding is the most common point of failure. The bootloader tools will completely crash if they are blind to the physical hardware. Now we execute the environment bypass. Run the command chroot/mnt. Watch the terminal prompt shift. This trick makes the session treat your temporary folder as the system's root directory. You're inside the broken server. It's time to rebuild. Execute grub2-install/dev/sda. This command forcefully wipes and rewrites the master boot architecture on the main drive. Immediately follow that up with grub2-makeconfig-o/boot/grub2/grub.cfg. This will scan the kernel and generate a fresh, uncorrupted configuration file. You will know the rebuild was successful when the terminal outputs this exact message: installation finished, no error reported. To execute a clean escape, type exit to return to the live ISO. Then run umount a to cleanly detach the physical drives from your temporary directory. Do not rush this final reboot. If you fail to safely unmount these directories first, you risk introducing secondary file system corruption to the machine you just repaired. Detach the temporary live ISO media from your console and initiate a final server restart. Instead of the cold, bare prompt on the left, the standard corporate OS boot sequence populates the screen, landing at the graphical login banner. Knowing how these components interact turns a potentially long outage into a repeatable troubleshooting process. When you understand how the system pieces itself together, you can fix it manually even when the automated tools fail. Don't wait for a crisis to learn this. Spin up a test virtual machine, deliberately wipe out your GRUB config, and practice this chroot recovery until it feels like second nature. While your test machine is installing, let me know in the comments, what is the most intimidating prompt you've ever faced down in production?